driving you crazy, or if you're finally admitting you're lazy, and your test grades have been dropping, it's time to get your arrows popping. Welcome everybody to the Algebra 2 Part 1 EOC. That's right, the end of course final exam review. We have Ashley in the house. What's going on, Ashley? She says she's back. Welcome back, Ashley. Good to see you. We're going to be getting into the final exam review. That's right, for the second semester. That's right, wrapping up the coursework for the end of the school year. We got Obina in the house. We got Aspect 7 in the house. Just dropping by to say what's up. I'll catch up with you in the fall when I start that college algebra class. Good job there. Charmaine is in the house. Arrows popping. Bang, 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 says Aspect. Empress Hodge is in the house. Let's go ahead and give you guys some love today. That's right. Give you guys some love. We got you guys in the house saying what's going on. And Mr. Witt is saying what's going on indeed. That's right. Obina says that she has finished up the school year. We got Simone in the house saying hello. What's going on, Simone? We got a witness in the house, guys. A witness is in the house. Simone is in the house, guys. We have Algebra 2 today. Algebra 2. And so just to let you guys know, I want you to subscribe to the YouTube channel for Ben Tutoring. Go ahead and do that for me. Go ahead and like the stream. Go ahead and share with your people. Go ahead and do that for me. I would appreciate that. Make sure you're commenting. Make sure you're sharing the love. Indeed, indeed. Don't forget to donate to Fort Bend Tutoring if you guys are able to. That helps us bring you more free math tutorials from Fort Bend Tutoring. Use the donation link in the description box as well as the super chat if you wish. Michael Burns is in the house saying I needed this 2 days ago. Sorry about that, Michael. But I'm here today, sir. I'm here today. Good stuff. All right. And as always, if I don't meet your needs in a timely fashion, then go ahead and set up a tutorial with me one-on-one and I'll help you out. You don't have to wait on me. Be proactive and go ahead and set up a tutorial with me, Mr. Witt, and Fort Bend Tutoring. All right, guys. So you are able to initiate the goodness that is Fort Bend Tutoring. Let's go ahead and get things started today, guys, as we are going to begin the final exam review for Algebra 2. That's right. And we're starting out with problem number 1 right here. Let me go ahead and get it in view for you guys. Let me go ahead and get it in view. Good guys. Michael says, I wish you taught accounting. You're the best. I appreciate that, Michael. I'm doing my best, sir. And I'm staying in my lane, Michael. I can do some accounting, but I'm better at what I'm doing right now, sir. I'm going to stay in my lane, but I appreciate the support always. Guys, we're starting out with a difference quotient. A difference quotient. They want us to find f of x plus h minus f of x divided by h for f of x being equal to 5 minus 3x. Oh, yeah. That's what we're going to do. And in order to find out the difference quotient, as you see here, and guys, this is just preparing you for calculus. This is preparing you for a calculus class as they're asking you to find the difference quotient. Oh, yeah. What's going on, sir? O'Shea is in the house. How you doing? O'Shea Duke Jackson is in the house, guys. Putting it on. Good to see you, brother. Always. Mr. Man helping it out. Helping out the community. I appreciate that. Let's first of all find out, guys, what our f of x plus h is. And you know what? Just because O'Shea is here, that just reminds me that I need to be writing in black. There we go. So that means that in order to find out this f of x plus h, we're going to be substituting every x in our function with x plus h. So we have 5 minus 3 times the quantity of x plus h. Once we have this set up, guys, we're going to go ahead and distribute. That's right. We're going to get our arrows popping right over here and find out that we have 5 minus 3x minus 3h. And this is the quantity that we are doing. Amen. Amen. That's right, Simone. We are preaching the math. That's right. We're going to preach it today. And I'm going to go ahead and circle this value here in purple. That's right. We got the purple circle in effect, guys. That's right. And now what are we going to be doing with this information? We already know that our f of x is equivalent to 5 minus 3x. We already know that f of x plus h is equivalent to 5 minus 3x minus 3h. We already have this. That's right. Ashley says, should I go to Cal or Trig? Also, I'm taking Algebra 2 next year. Any advice? Well, Ashley, I suggest that you combine the two and go ahead and take pre-Cal if you haven't taken pre-Cal already. What's going on, mobile gaming? So if you're confused about whether or not you should jump into calculus or a trig class, you will need trig for calculus, but you can combine that preparation in a course like pre-calculus that will go ahead and prepare you for everything that you'll be tackling in calculus, but at the same time, it will go ahead and enrich your trigonometry at the same time. So it's almost like taking an Algebra 2 class combined with a trigonometry class in order to prepare you for a calculus class. And we got O'Shea Duke Jackson, guys, with a $20 super chat. Oh my goodness, keep teaching, professor. I'm going to go ahead and show you some love, guys. This is O'Shea Duke Jackson with the donation, and you better recognize. Good stuff, sir. Good stuff. This is going to be on and popping, guys, and let's go ahead and get that donation shout out clear for everybody to see. O'Shea Duke Jackson, just go ahead and drop $20 in the super chat, guys. That's what's going on. I appreciate that. Check out this channel, guys, as he has some great information to keep you moving in the positive direction. All right, go ahead, O'Shea. Go ahead and email me later. I look forward to it. Obina is in the house. Olivia is going on. This is so good, so clear. Let's go ahead and continue, guys. So for starters, we found out that we were given the value of f of x, that it's 5 minus 3x. We were also given the quantity of, we were also going to find the quantity of f of x plus h, and we substituted that value in. For every x in our original function, we replaced it with x plus h. And now we're going to combine all this in the difference quotient. So the difference quotient says to put our value of excuse me, let me get my words together here. It says to put our value of f of x plus h into the numerator. Let's do that. So we have 5 minus 3x minus 3h. And we're not going to do it in purple. We can't do it in purple, guys. We got to do it in black. We have 5 minus 3x minus 3h. Then it says minus the quantity of your function f of x, which is 5 minus 3x. So all I'm doing is I'm plugging in the values into the difference quotient that you see right here. So the difference quotient is that f of x plus h minus f of x divided by h. We started out with the given amount of f of x. We didn't know what that f of x plus h was, so we found it out. We put it in the purple circle. Then O'Shea Duke Jackson dropped $20 on us, so we had to give him some shout outs. And now we're back into our problem, filling in those information, filling in the information here, and it all needs to be divided by h. That's what we have right here. Oh yeah, that's right. Purple, Ashley. We got the purple going on here. Let's go ahead and continue this problem. Now we're going to be simplifying, guys. So we're going to be distributing the negative here, okay? And distributing that negative, we'll rewrite this as the following. Let's go ahead and check it out. We'll have 5 minus 3x minus 3h minus 5 plus 3x all over h. Then from here, all right, you said that you ended up with a negative 3, Obina? The negative 3? Oh, gotcha. The negative 3 came from the f of x. F of x is equivalent to 5 minus 3x, Obina. All right. They want us to also use in our difference quotient the value of f of x plus h. And this is when we replace all the x's in f, in our f function, with x plus h. So what I did was I brought down that 5. Then I ended up with the negative. Oh, I see what you said. Obina says that her answer is negative 3. Very good, Obina. But for everybody else, we then replaced that x with x plus h, and we simplified, and now we're going to plug in those values into the difference quotient. And Obina, guys, already has the answer. That is correct, Obina. Specify what you're giving me now. So now what happens is our 3x's will cancel out, guys. The 5's will cancel out. And we have now negative 3h over h, and guess what happens? Those h's cancel out, so we end up with Obina's correct answer of negative 3, and this is our answer here, guys. Oh yeah, good deal. We have negative 3 ladies and gentlemen, for the result of that difference quotient. Obina had the correct answer, and we're moving on. And once again, another shout out to O'Shea Duke Jackson with the Polish dollar. That's right, $20 in Polish, in that Polish unit of measurement there. All right, the Polish currency. I think that's what I was trying to say. But we're going to be moving on to problem number 2, guys, as we are to use composition to determine. Shub says, thanks for the video. That's right. We're going to put a red box on that, Michael Burns. You already did. Did I forget my red box? No, I got my red box, Michael. That's right. We had to put it in a red box. There we go. All right, let's move forward. We had a whole lot of going on in that first problem, guys. We had a whole lot going on in that problem, and now we're moving on to problem number 2. It says, use composition to determine if the following pair of functions are inverses of each other. That's right. Simone, what you talking about no for? What's going on with the no? I say yes, Simone. Why are you saying no? We're going to be using composition, guys. We're going to be using composition to determine if the following pair of functions are inverses of each other. So we have f of x. All right. You say I would have said something. Okay. The following pair of functions are inverses of each other. Let's go ahead and figure this out, guys. So for starters, they gave us the functions f, they gave us the function g, and what will happen is if these two functions are inverses of each other, the following would be true. It would be true that the composition of f and g of x would equal to x. And if these are inverses, then the composition of g and f of x would also equal to x. So this is how we can use composition to confirm that we are dealing with inverses. That's right. So taking the composition of f and g, if that equals to x, and if you take the composition of g and f, and that also equals x, you are dealing with inverse functions. That's right. So we end up with Ashley in the house. All right. Oh, man, I have to go. All right. Good stuff. Well, congratulations on Ashley on singing that anthem at a football game. Good stuff. Yes, right. And I will be doing another Algebra 2 lesson this Saturday, Ashley, so you can catch that. All right. Good stuff. And Noah says yes. All right. That Simone is correct. All right. Well, I want to know what Simone was supposed to be correct about, because I'm still a little confused about what she was saying about that. So y'all gonna have to clarify what she was talking about. Shub says her Algebra 2 final is that his Algebra 2 final is tomorrow. Your videos are really helping me out. I am trying to help you out, sir, which means I need to get back to this problem. So first of all, we're going to find out what f of g of x is. This is going to be our first composition, which means I'm going to replace every x in our f function with the entirety of g. Let's see what that looks like. We'll end up with the numerator. Instead of it being x, I'm going to put the function g there. It'll be 4 times the quantity of x plus 3/2, all divided by 4 plus 3/2. And these are some ugly 4s, guys. I don't know where these 4s were imported from, but they need to be returned immediately. So let's see what we can do on the number 4. I think these are better 4s. Yeah, those 4s are better now. All right. Oh, you said no as in I didn't forget. Thank you. All right. Tony says my son he's got this. Good job, Tony. You and Noah should have it. What happens next, guys, in simplifying this is that our 4s will cancel out. We'll bring down the x plus 3/2. All right. And I think I should have minus. Yeah, that's a minus 3/2, guys. I was rushing. This should be a minus 3/2 here. Keep me honest, guys. Don't let me make mistakes in this live stream. We'll have x minus 3/2 plus 3/2 here. There we go. So what happens next is that the 3/2 will cancel out, correct? That negative 3/2 there and that positive 3/2 there. And guess what? The composition of f and g, it does equal to x. That's exactly what we want to happen, guys. We want that value to be x. But it means nothing to us if the composition of g and f don't also equal to x. It has to also equal to x in order for these to be inverses of each other. Inverses says I just got the answer. I shouldn't spoil it this time around. You can do what you like, Obina. You can do what you like. I'm not going to hold you back today. All right. You go ahead, Obina, and you go ahead and give us the answer if you want to. But just next time, just say the answer is, so I can know that you're not referring to a step. All right, good deal. Now, finding out the composition of G composite F, we'll have this setup. We'll say G of f of x would equal to what? All right, so we'll be plugging in our function f for every x in G. So we'll rewrite the G function as 4, and I'll go ahead and say times the quantity of x. Oh, no x, no x, no x, no x. We're replacing it with our f function. This will be x over 4 minus 3 halves. There we go. I'm going to get it together, guys. I'm just warming up, okay? I'm just warming up here. So I replaced our x in G with the function f. That's why I have 4 times the quantity of x over 4 minus the 3 halves plus that 3 halves from our function g there, okay? So what happens inside the parentheses, do you know? Well, you should know that these additive inverses will cancel out, right? So we're left with 4 times x over 4, and then the 4's will cancel out to leave us with another x. And that's what we wanted to happen, guys. We wanted the composition of f composite g as well as the composition of g composite f to both equal to x. If they do, then the answer is yes, they are inverses of each other. So yes, they are inverses, and Obina has the correct answer. We're going to, of course, guys, we're going to, of course, put that in a red box. That's right. So the answer is yes, ladies and gentlemen. And that was problem 2 as we were confirming inverse functions by using composition. Oh, yeah. Amen, amen. And I love doing problems like this, guys, for you, because many of these problems that we do during the review of our final exams are not currently available on the YouTube channel in the form of a video. So it's like I get to showcase all these different math concepts that I haven't made a video for yet, all at once within the final exam reviews. That's right. What's going on, Derrick? Good to see you. Good to see you. You did not miss everything, Derrick, because we are just getting things started up here. We're just on problem number 3 now. Evan says the way I did the question is just to replace the f of x with a y, then just make the x right. What you did, Evan, was you took one equation and you algebraically found the inverse. But the directions for that last problem was to use composition to solve it. So it's not as though your method doesn't work, Evan. It's just that they told us which method to use. So we had to use composition by way of the problem in order to solve that previous problem to confirm that those two functions were inverses of each other. All right. Good stuff, Evan, though. You keep it up, sir. Now we're going to be taking in problem number 3, guys. We're going to be expanding this natural logarithm, all right, into its expanded form. There you go. I don't know how else to say it. We'll be expanding this problem, all right, this natural logarithmic problem. That's what we'll be doing here. So the first thing I'm going to do is I'm going to rewrite the quantity that we have in exponential form. Let me show you exactly what I'm talking about here. I'll be rewriting this by saying that this is the natural log of our quotient x and y, our quotient x divided by y, raised to the 1/3 power. All right, that's what I have there. So we're going to be using logarithmic rules in order to expand this problem here, guys. And for any of you that want to see more examples or more final exam review as far as Algebra 2 is concerned, check out our college algebra final exam review, because Algebra 2 in high school is equivalent to college algebra in many cases, guys. There's only maybe 1 or 2 random concepts that differentiate the two. All right, that makes them different from one another. But overall, they're pretty much the exact same class. So anytime you want to prepare more for your Algebra 2 final exam, guys, check out our already posted college algebra final exam review for more problems that can help you in preparing for your Algebra 2 final exam. But also let you know that I will also be posting the Algebra 2 final exam review part 2 very soon. Obina says, this is just problem 3. That's right. We're just on problem 3. Exactly. Tony says, my son would love to share some more of his knowledge, everyone, but he has a lot of work he needs to do. All right. Good stuff. Good stuff, Tony. So you and Noah, you guys take care. Thank you for stopping by. I appreciate that. Let me go ahead and put the chat back on the screen there so you guys can know that there are real people out there in the world that are engaging with Fort Bend Tutoring Live. TK just got here. Hope I didn't miss anything important. Not too much, TK. You're good to go. So now, guys, we'll be using the exponential rule for logarithms, and this exponent here will become a coefficient of our expression. So we can rewrite it as 1/3. Notice that I brought that exponent in front as a coefficient. It'll be 1/3 the natural log of x divided by y. Now, using your quotient rule for logarithms, anytime you have division going on, you can expand that into subtraction. Let me show you what I'm talking about. That this can be rewritten as 1/3 times the natural log of x minus the natural log of y. And then to continue this, we'll go ahead and distribute. That's right, we'll get those arrows popping here to distribute that 1/3 so that you'll end up with 1/3 times the natural log of x minus 1/3 times the natural log of y. And this is our original problem expanded. Amen, amen. So that was expanding a natural logarithm. You got it. That's it right there. There it is, guys. That's the answer to problem number 3. And we, of course, put a red box around our answer. Oh, my goodness. I just knocked the camera. So excuse me for that drawing effect that you had there. But here's problem number 4. All right. Let's make it up with problem number 4. How about that? With problem number 4, we have another logarithmic problem. However, this is a logarithmic equation. Yeah, that's exactly what it is. So we want to solve for x, guys. And, guys, look at this. We got Tony in the house with a donation. Thank you, Tony. Good job. So Tony used that PayPal link that you can find in the description box, guys. So Tony so we're going to say Tony and Noah up in this piece, guys. Let's go ahead and give them their proper respect. We got Tony and Noah with the donation. I appreciate that donation, Tony and Noah. You guys take care. I appreciate your patronage and always being present in the live streams. Amen, amen. Good job, guys. So let's keep it moving, guys. We have this logarithmic problem. Let's first of all see what we can do in order to solve this problem. For one, we can go ahead and use our exponential rule that we just talked about. Notice that this coefficient in front of the first term can become the exponent on our value for the logarithm. In other words, I can rewrite this as log base 3 of x squared. Notice how that 2 became an exponent here, minus log base 3 of x minus 2, and this equals to 2. All right, there we go. Logarithms are a different way to write exponential notations, Simone, so they work hand in hand with one another. Okay, so what you could do to get some background on the logarithms is check out my video on logarithmic equations, as I discussed that transformation, that conversion from logarithmic form to exponential form. It's just a different way of writing exponential notation. All right, Obina is coming through with the suggestions and the advice in that area. Way to go, Obina. That's right. So yeah, so one of the things that you can pick up on is that you can dive into how to use logarithms, Simone, and I do have several videos that are already posted on there. Matter of fact, Simone, go ahead and check out the playlist called Logarithms by Fort Bend Tutoring, and you can see a lot of work dealing with logarithms in that playlist. All right, good stuff. Thanks, Obina, for your assistance there and giving her the conversion. So what we're doing now then, guys, is because we have subtraction on the left side, we can also rewrite 2 with a logarithm. So I'm going to go ahead and show you guys this strategy because I haven't presented this strategy to you guys in my previous videos. So let me show you what you can do on the right side. On the right side, we can rewrite 2 with that same logarithm with that same base of 3 by writing the right side as the logarithm of base 3 of 3 to the second power. Okay, because that is equivalent to our value 2. Because using your logarithmic properties, that log base 3 and that 3 would cancel out to give you the value of 2. The reason why I wanted to express it on the right side this way is to show you this different strategy, as well as I will be going toward having one logarithm equal to another logarithm, and there's a special property that coincides with that, and that's why I'm going to show you this strategy in this problem right now. On the left side, we have subtraction with the same logarithmic base. That means we can convert this into using the quotient rule for logarithms, log base 3 of x squared over x minus 3, and then this would equal to log base 3, And you can say that 3 squared is 9. Okay? Yeah. So now that we have this equation set up to where we have one log equal to the same log on the other side of the equal sign, then the values that they represent must be equal to one another. In other words, we can cancel out these log base 3's now. And we'll set up a proportion as x squared over x minus 2 must be equal to 9 over 1, writing the equation as a ratio. Amen, amen. From here, we have a proportion, we have a fraction set equal to another fraction, which means we could use the extremes means method. In other words, I can cross multiply, guys, so I definitely have my arrows popping as I do this. We have 1 times x squared, which gives you x squared. This equals to x minus 2 times 9, and I'll just write it as 9 times the quantity of x minus 2. And now we just have a quadratic equation now to solve. So we did all of those logarithmic properties so that we can end up with this quadratic equation. All right? Yeah. So once we have this, let's just go ahead and distribute, get those arrows popping again, get those arrows popping, and set this equation equal to 0 eventually. So on the left side, I'm distributing the 9. So I'll end up with the x squared equals to 9x minus 18, right, guys? Then I'll be subtracting 9x to both sides, as well as adding 18 to both sides. Oh, yes, I will. Oh, yes, I will. Just like so. And then to sum up this mess, we'll have x squared minus 9x plus 18. This equals 0. Amen, amen, guys. So we could actually try to factor this, right, in solving this quadratic equation. So we would need 2 factors of 18 that would add to give you 9. And in that case, you're looking at 6 and 3, right? So let's go ahead and factor this. So we have x minus 6 times x minus 3 equals 0, and then set each one of these factors using the 0 factor property equal to 0 and solve for it. So we'll have x minus 6 equals 0, we'll have x minus 3 equals 0, and then we'll solve for x in each of these equations by adding 6 to both sides to get x equals 6, and also by adding 3 to both sides as well to get x equals 3. That's supposed to be a 3. And now you need to check for extraneous solutions, because you need to keep in mind that you cannot have the log, any log, that equals to 0, or in other words, you can't take the log of 0 and you can't take the log of a negative value. So you have to be aware of the domain restrictions when dealing with logarithms. All right. You can never take the log of 0. You can never take the log of a negative number. So make sure you're plugging these potential solutions back into the original equation to see if they are within the domain. There you go. All right. So let's go ahead and plug in 6 to see if that works. Plugging in 6 to the original equation, we would just be taking the log of 6. That's a positive number, so that's okay. 6 minus 2 is 4, so taking the logarithm of 4 is okay. So those work just fine. That number works just fine. Plugging in the 3 here, 3 is fine when you plug it in. And 3 minus 2 is 1, and it's okay to take the log of 1. So once again, I was checking to make sure that my potential solutions did not violate the domain restriction for logarithms. Once again, you cannot take the logarithm of a negative number or 0. So I'm trying to draw a brace right now, guys, so that my solution set is 3 and 6, which is exactly what Obina has as an answer. That's right. 6 and 3 is the correct answer, guys, for problem number 4. That was solving a logarithmic equation, and I showed you a technique that I didn't show you guys in a previous video. So there you go. By watching the live stream, by watching Fort Bend Tutoring's live streams and our final exam reviews, you get more strategies for solving these problems. And now we're on problem number 5. As they were asked to simplify completely, we are asked to simplify completely. Let's get the chat back on the screen. Amen, amen, guys. The chat is back up. And here we go. Simplifying completely, guys. In the numerator, we can start by factoring out a 4. Notice that every term in the numerator is factorable by 4. When you're simplifying a rational expression as we are right now, you want to try to factor the numerator and the denominator completely. And the GCF, the greatest common factor in every term in the numerator, is 4. So we're going to factor out that 4. So we'll end up with 4 times the quantity of x squared plus 3x plus 2 all over the factorization of x squared plus 5x plus 6. In other words, I would be looking for two factors of 6 that add to give me 5, and that would be 3 and 2. So we'll write this as x plus 3 times x plus 2. Amen, amen. How you like that? So what happened so far in the numerator? I know Simone is on top of this. In the numerator, we factored out our GCF of 4. In the denominator, guys, we factored out the trinomial in the denominator, that quadratic trinomial. So we ended up with x plus 3 times x plus 2. What's going on, Cherished? How you doing? I like your Pikachu avatar. That's right. Pika P in the house. Cherished. Good of you to stop by. So then, continuing to factor in the numerator, we're looking for two factors of 2 that'll add to give you 3, and that'll be 2 and 1. So you'll end up with x plus 2 times x plus 1 in the numerator all over that factorization of that quadratic trinomial from earlier, which was x plus 3 times x plus 2. That's right. Yes, you do factor the numerator completely, Derek. So I started out by factoring out the 4, and then I continued to factor the numerator by factoring out that quadratic trinomial to end up with 4 times the quantity of x plus 2 times the quantity of x plus 1. So you're right, Derek. You do completely factor the numerator as well as the denominator. But our numerator had a 2-step factorization process. You factor out the GCF of 4. Then you continue factoring in the numerator by factoring that quadratic trinomial x squared plus 3x plus 2. So absolutely right, Derek, in that process, sir. You know what you're doing, sir. I appreciate that. Now we're going to be simplifying what we can. So any like factors, any identical factors that we find, we can cancel out. All right. And remember, when they cancel to 1, not to 0. So that means that the x plus 2 will cancel out to 1. The x plus 2 in the denominator cancels out to 1. And then we'll multiply the numerator together to say that we end up with 4 times the quantity of x plus 1, knowing that 1 times anything is itself. And x plus 3 times 1 just gives you x plus 3. So we have our answer, guys. This is it. This is what's up. We got our answer right now. It's going to be 4 times the quantity of x plus 1 times divided by the quantity of x plus 3. And we're going to put a red box around our answer, ladies and gentlemen. That was problem number 5. How you like that? Yeah. We're just moving on. We're just moving on here to problem number 6. To problem number 6, as they ask us to simplify this complex fraction. See, if you want to see more examples of problems like number 6, check out our video called Complex Fractions. Amen, amen. Oh yeah, that's what you want to do. So notice that we have fractions within fractions in this complex fraction here. And so the technique that I will be using in order to simplify this is multiplying each and every element within this complex fraction by the overall LCD. That's right. So we'll be converting this, Cherish, by multiplying each and every term by the LCD of 3. That's right, the overall LCD of 3. So I'll be multiplying every term in the numerator. All right, let me get off that red. Get back to my black here. Back to black. Thank you. That's right. So we'll be distributing 3 to each and every term in the numerator. All right. And what I'm going to do, guys, for you is I'm going to have an area over here, and I'm going to call it my slow motion area. That's right. To show you each and every step that I take as I simplify this complex fraction. Let me show you. We're going to start out by getting my arrows popping here, okay, to show you that every element within this complex fraction will be multiplied by my overall least common denominator of 3. And over here on the right, I'll be showing you that process. So let's start out with the first element here. Let's start out with that 2. We're going to be multiplying 2 times 3. All right, well, that's still 6, right? Yeah, it's just still 6. So we'll just have a 6 here. Then I'll be multiplying the negative 1/3 times 3. What happens there? My 3's cancel out, and I have negative 1 as a result. So this is going to be minus 1 now in the numerator. Then in the denominator, we'll be multiplying by 4 next. So I'll say 4 times 3. And you guys know that 4 times 3 is 12, right? So we now have 12 in the denominator. That's right. And now we'll be multiplying 11/3 times 3. And when we multiply by that 11/3, guys, those 3's will cancel out to leave me with 11. Yes, it will. So that means that my result, even, that's right, Evan has the answer. Evan has the answer, which is 5/23 done and done. And this is how we simplify a complex fraction, as Mr. Witt would do. Amen, amen, guys. And we, of course, put a red box around the answer. That's right. We're going to show off with that red box around the answer. That's exactly how we roll. You see what I'm saying? Yeah, we got to let these teachers know. Don't waste our time with problems like this. Okay? Go ahead and give my A, teacher. That's what you tell them. There you go. So Evan says, wow, you have a fast method. Cherish and Evan, I do not like to waste my time. I'm too lazy for that. I'm too lazy to be spending all day on one problem. Evan, let's go ahead and get this stuff knocked out. So notice that I have my slow motion area over here to the right, guys, as I break down how I multiplied every term in the numerator and the denominator by 3. That overall least common denominator. It assisted me in breaking down the complex fraction. Oh, I will not be held back. Not today. So I have my slow motion area over here. And I took the results of that slow motion area and I put them back in their proper place. I put the 6, the -1 in the numerator. I put the 12 and the +11 in the denominator. And then I simplified that and I got what Evan got in his answer, which was 5/23. And I put it in a red box. We put it in a red box. So guys, this is at the point in the final exam review where I want to remind you that you can set up a paid online tutorial with me today, Mr. Witt. That's right. Check out our YouTube channel, Fort Bend Tutoring. All right. Check out our YouTube channel for Fort Bend Tutoring, which is tutormemath.net. That's right. tutormemath.net. Cherished says that I wish you were my math teacher. I can be your math teacher by doing just as I suggested right then, Cherished, by setting up a paid online tutorial. And Angry Hermit is in the house. Let's go ahead and show Angry Hermit a little love in here, guys. There we go. Angry Hermit is in the house. What's going on, Angry Hermit? There you go. Simone says she wishes the same thing, that I could be her math teacher. Well, I can, guys. Dupes, what's up? How you doing, Dupes? I like that Yoshi avatar that you got, Dupes. Yoshi is in the house. All right, guys, let's continue on with problem number 7 as we are solving a rational equation. All right, Angry Hermit says I may not stay long because I have to cook dinner. I understand, Angry Hermit. All right, being as though you have to cook a big dinner for yourself because you have no one else to cook for because you are an angry hermit, which means you're by yourself. Dupe says, can you teach me how to simplify algebraic expressions? Absolutely. Dupes, we just got through simplifying an algebraic expression a couple of seconds ago, and we'll have some more throughout this final exam review. And you can also check out our YouTube video, Dupes, called Simplifying Algebraic Expressions. And if you want extra help on top of that, remember I just said that you can hire me as your tutor and go to tutormemath.net and set up a paid online tutorial, and I will help you out one-on-one. That's right, Dupes. It'll just be me and you. Right now, Michael, the charge for the online tutorials are $1 per minute, and you can set up an online tutorial with me as little as 15 minutes. So it would be $15 for 15 minutes, or it could be $60 for an hour. All right, and you can set up a tutorial for as long as you need. There you go. How about that? All right. So most people will cap out at about 2 hours. So there you go. There you go, per session. And you can set up as many sessions as you like. And it's at will. See, there's no contracts involved in that, guys. All you got to do is say, hey, I want you on this day. You go ahead and pay for it, and we go ahead and do it. That's it. It's simple. So Angry Hermit says my family is well, and she says that I will cook for my family. Will you do a good job cooking for your family, Angry Hermit? All right, and wish them well and tell them I said hello. Javier is in the house and says that is nice. I would assume that the service that we provide is nice. I'm doing my best, Javier, trying to help as many people as possible, as well as keep the lights on. So that means that when we do personalized tutorials, we must charge for that because that helps us eat. And you want Mr. Witt and company to eat, guys. All right, let's keep moving because this is a final exam review for Algebra 2. And just to keep you guys aware, Algebra 2 is equivalent to college algebra. So everything else on the YouTube channel for 4-Bit Tutoring that says college algebra, you can use it in preparation for your Algebra 2 exam. All right, let's continue. So what we're going to do, because we have a proportion, that's right, a fraction set equal to another fraction, all you have to do is use the extremes means method. That's right, cross multiply, guys. So I'm going to show that I have x times x plus 1 equal to the quantity x minus 3 times the quantity 2x plus 5. See, I'm just taking my time with it as I set up the problem. So cross multiplying this situation, and you can only cross multiply, guys, when you have one fraction set equal to another fraction. That's it. That's the only time you can use cross multiplication. There it is. Michael says, what time is it there now? Right now, it is 4:16 p.m. where I am right now. I'm in Houston, Texas, Michael. That's right. But it doesn't matter, because as long as you can be all over the world, Michael, we can sync up our times and get that tutorial offered. That is the beauty of the internet. All right. So there are no restrictions. Okay. That's right. Obina says Houston is in the house. So, Michael, wherever you are in the world, as long as we sync up our times and as long as we can set those times together, we can set up a time to assist you. So don't put any bounds or boundaries or time restraints on that offer. It can be set up, all right, if humanly possible. All right, so here's the deal, guys. We're going to go ahead and get our arrows popping. That's what we're going to do. So I'm going to get my arrows popping here. That's exactly what I have. I got arrows popping, guys. So on the left side here, I have x times x is x squared. X times 1 is x. This equals to x times 2x, which is 2x squared. We have x times 5, which is 5x. We have negative 3 times 2x, which is negative 6x. We also have negative 3 times 5, which is negative 15. And if you guys are new to Mr. Witt, new to me, you should know right now that the distributive property is my favorite property, guys. You know, I love to get my arrows popping. All right. So this is a perfect problem for me. So continuing on in this process, on the right side of the equal sign, I will be combining my like terms. So I'm bringing down this 2x squared on the right side. 5x minus 6x is negative x minus 15. And it's at this point, guys, that we definitely have a quadratic equation. And we want to set the quadratic equation equal to 0. Let's go ahead and see what it looks like as we set this quadratic equation equal to 0. That means I'll be subtracting x squared to both sides as well as subtracting x equal sign. Let's see what this looks like here. Everything on the left side of the equal sign will cancel out. I'll be bringing down x squared minus 2x minus 15 equals 0. This is what I have. Amen, amen. And hopefully, guys, this quadratic equation that we have before us is factorable. All right. We can find out for certain by looking at that last coefficient of 15 and looking for two factors of 15 that would subtract to give us 2, which is the middle term's coefficient. So 2 factors of 15 that would subtract to give us 2, that would be 5 and 3, right? So let's go ahead and open up 2 sets of parentheses here. So I have my variable x, I have my factors 5 and 3, and the sign of the largest factor will always be the sign of the middle term's coefficient. So that means that the 5 must be negative, and because we're subtracting to get that 2, the 3 needs to be the opposite sign. So the factors that we need, Derek, are going to be 5 and 3 using the negative 5 and a positive 3 here. So from this point, let's go ahead and use the zero factor property and solve for x by setting each factor equal to 0 and then solving for it. All right, I hated that equal sign there, so we're going to fix that equal sign because it was ugly. That's right, we can't be presenting no ugly work to the public now. That's just rude. We don't want to be rude when you're setting up your work here. All right, you're trying to help people. Can't help people if they can't read your writing. You know what I'm saying? So we got to hook this up. Amen, amen. We end up with x equals to 5 as well as x equals negative 3, guys. So as a solution set here, let's see if Mr. Witt can write a brace because he sucks at his braces. There we go. That's a decent brace, guys. I'm happy with this brace. All right, not so much with the right one, but that left brace has got it going on. And we will red box our solution here. And also, guys, we got to keep in mind that these solutions will not violate the original equation's denominators, because you have a domain restriction when dealing with rational equations. You can have a value of 0 in the denominator, guys. Okay, so notice that when we plug in -3 into the denominators here, that it doesn't generate a 0 in either denominator, as well as when we plug in a 5. All right, okay, good deal. Good deal. Let's continue on, guys. That was problem number 7, as we put a red box around our answer, and we got Saya in the house, guys. What's going on, Saya? How you doing? Let's go ahead and move on to our next problem here. We have problem number 8. That's right. Obina says, well, both solutions are legal anyways. So, yes, both solutions are legal anyways, but Obina, part of your process means that you need to check to verify that they are, in fact, within the domain of the original equation before you call it a solution. Angry Herman is saying, what's up to Saya? Good deal. Good stuff. All right. I'm doing just fine. Saya, I'm doing even better because you were able to join us today. So thank you for coming through, Saya. All right. Showing your love to Angry Herman as always. Let's look at problem number 8, guys, as we have graphed the following rational function. We have f of x equals to 2 divided by x minus 5. All right. So in this, we're going to do several things. We're going to start out actually by recognizing what asymptotes that we have within the problem. And guys, trust me, I know I'm pronouncing that wrong, but I can't say it right. So we're going to be looking for vertical asymptotes. We're going to be looking for horizontal asymptotes, any oblique asymptotes that we may have. We're going to be checking all of that out. All right. So once again, please forgive me. I am aware that I always pronounce that incorrectly, but I'm going to be all right because I know how to do it. How about that? Okay. So while you're pronouncing things correctly, I'm getting the right answer. So as far as our vertical asymptote is concerned, you're going to be setting the denominator equal to 0 and solving for it. So I'll have x minus 5. I'm going to set that equal to 0 here. I'm going to make this a colon. There we go. And I'll be adding 5 to both sides to give me the equation of the vertical asymptote. So this is going to be x equals 5 is going to be the vertical asymptote. The vertical asymptote class, ladies and gentlemen, guys and gals, is going to be where our function cannot touch. It will not be able to touch this vertical line that we'll be drawing right now. So it's clearly x equals to 5. So we'll have a vertical line going through 5 on our graph here. We also have a similar horizontal asymptote. However, it is possible for the graph to cross the horizontal asymptote depending on the function. So in order to find out the horizontal asymptote, what we're looking for here is we're looking for the fact that if we were to show all of the degrees in the numerator and the denominator, if you have a smaller degree in the numerator than in the denominator, then your horizontal asymptote will be 0. Let me show you what I'm talking about. We could show that this numerator could be written as 2x to the 0 power divided by x to the first power minus 5. You get your degrees from your exponents on your variables, guys. So notice that since the numerator was just 2, which is equivalent to 2x to the 0 power, that the degree of the numerator is 0. Whereas the degree of the denominator, because our variable x is to the first power in the denominator, the degree of the denominator is 1. So as long as the degree of the numerator is less than that of the denominator, your horizontal asymptote is going to be y equals 0 every single time. And with that in mind, we'll go ahead and show with a dashed line that basically the x-axis will be our horizontal asymptote. That's what we're looking at. Okay? In addition to this, we can now show that the solution of this, or the graph of this, can be easily found by finding our values of y on the opposite sides of our vertical asymptote. So basically, I'm going to be setting up an XY chart here, guys. All right, because there are sometimes that they request to have the x-intercepts and the y-intercepts, but I'm bypassing all that because I'm just asked for the graph in this problem. So we want to find out what happens to the left of 5 on the x-axis. So I'm going to have 2, 3, 4, and we also want to find out what happens on the right side of the vertical asymptote. So I'm going to use 6, 7, and 8. All right, so let's plug in these values into our equation to find out what happens. If we plug in 2 into our rational function, we will be able to simplify 2 divided by 2 minus 5, right? So this gives us a negative 2/3 as a result. So this value is negative 2/3. However, when I plug in 3 into this denominator, we'll have 2 divided by 3 minus 5. That gives us 3 divided by negative 2, which is negative 1 as a result. Okay. If I were to plug in 4 into our original function, we'll have 2 divided by 4 minus 5, which is 2 over negative 1. That gives you a result of negative 2. So all I'm doing is plugging in my values of x into our original function and simplifying it. All right. So these are giving me points on my graph that I can use to graph the line. Now, many of you will be told that you can go ahead and sketch the rational function, but I don't believe in sketching in a math class. I don't believe that wholeheartedly, because if you're sketching a graph, that leaves things up to the teacher, to the instructor's interpretation. All right, or how they're feeling that day, or how they like you, or if you pissed them off the previous day before the test. You see what I'm saying? It's subjective at that point. A sketch is subjective to whoever is viewing it. So if your graph is close, depends on how the instructor feels that day. Yeah, this graph is not close. This graph is close. So don't give them any leeway. Go ahead and give them the exact graph, and therefore you know that your answer is going to be correct. All right. So I strongly promote actually graphing the exact graph versus you going ahead and going with a sketch to save time in some cases, but you're leaving your answer subjected to your instructor. All right. And I don't trust any of them. So here we're going to go ahead and plug in 6. We'll have 2 divided by 6 minus 5. That's going to be 2. That'll be 2 over 1, which is 2. Plug in your 7. You'll get a positive 1. Plug in your 8. You'll get a positive 2/3. And now we have 6 points to graph. All right. Good deal. Mr. Saya says, Mr. Witt, can you also make a later video on how to deal with 2 or 3 exponents, like 2 to the negative 3x squared? Oh, got you. All right. Yeah, that's fine, Saya. But in a problem like that, you just find out that it's 2 to the negative 9th power and then put the base in the denominator. So you'd end up with 1 over 2 to the 9th power. All right. Angry Herman says, also teachers are more likely to give their students poor grades if they grade later in the day because people make worse decisions when they're tired. Wow. Yeah. But like I said, Angry Herman, you don't want to leave this up to how the person feels or what they think about you. Just give them the exact graph. You don't have to worry about it. So here you're going to have 2 and negative 2/3. That's going to be 2 and negative 2/3. So 2 negative 2/3 is going to be almost a negative 1. It's going to be right there. We're going to have 3 negative 1. That's going to give us a value right there. We're going to also have 4 negative 2. That gives you a value right here. So what's going to happen, guys, especially if you're familiar with your parent function for this, your graph is going to look like this. All right. And then let's see what happens on the other side of the vertical asymptote. You'll have 6, 2, so that gives me a point here. We'll have 7, 1, gives you a point here, and we have a point 8 2/3 that gives you a point about right there. So that means that this side of the graph will look like this. There you go. And we have our exact graph, guys. And notice that I'm showing you how to do this while teaching and answering questions in the chat. So you doing this on your own in the middle of a test, it's not going to take you any time at all. All right, it's not going to take you any time at all to solve that problem, okay? So what you need to know is that you can tackle this problem in a time-efficient manner and get the exact graph, not worrying about a sketch, and being confident moving forward in your test, knowing that you have the exact graph graphed. Not just a sketch, but you're giving the instructor exact points on the graph to verify your results. Okay, so therefore it's irrefutable. So now you have Angry Hermit saying, what time are you teaching next week? This Saturday, I'll be at 10 a.m. And next week, guys, because this is going to be the last final exam review for now, we'll be going to work on some various concepts in college algebra courses. And we'll be doing probably just weekly live streams from there. I'm going to go back to doing some studio live streams, okay? So we'll probably just be once a week. So it'll either be on Thursdays or it'll be on Saturdays. Most likely, let's go ahead and say it's Thursdays. So on Thursdays or maybe even Wednesdays, I'll be doing live streams going forward, guys, after this weekend. All right. Good stuff. Cherished says, but most importantly, make sure you're doing what the question is asking you and you'll be fine. That's correct, Cherished, but you will never be counted incorrect for giving an exact graph when they tell you the sketch, though. You see what I'm saying? So your sketch, your version of your sketch could be the exact graph, and you won't be counted wrong on that. Tutorial YouTuber said, I would like to thank you. I watched your Algebra 1 final review and got an A on my final exam. Good stuff. And your grade was a 78%, and now it's an 83. Tutorial YouTuber, you are awesome for going to the extent of looking for help online, finding it, and executing it. Good job. Congratulations on your final exam, man. That is awesome. And you said that you used our Algebra 1 final exam review? That is wonderful. That's the thing I want to hear back from you guys. Let me know if the tutorials that you found on Forbidden Tutoring are helpful. Good job on that. I'm so proud of you, tutorial YouTuber. You are amazing. All right. Good job. All right, guys, let's go ahead and move on to problem number 9. That's right. In problem number 9, it says to find the equation of the oblique asymptote. Remember earlier we were referring to finding the vertical asymptotes, finding the horizontal asymptotes. If you're going to be finding an oblique asymptote, it's going to be a situation where the degree in the numerator, notice that we have x squared here, is going to be one more than the degree in the denominator. The degree in our current denominator is 1. All right. So in order to find out the oblique asymptote, we're going to use long division. Tutorial YouTuber says, I like it because you teach like my math teacher. Well, good. That means that your math teacher is a boss, tutorial YouTuber, if they teach like me. All right. Angry Herman says, yeah, I learned all the concepts from my placement test last minute using your videos, and I did pretty well. Wow, Angry Herman. Good stuff. I did not know that. That's the first time you told me. All right. Well, congratulations to you, too, of course, Angry Herman. You know I support you and your dinners that you cook. All right. So this is what you're going to do, guys. If you want to find out the equation of an oblique, a.k.a. a slant asymptote, all right, because they're also called slant asymptotes as well, all you need to do is use long division on the function. So we'll have the divisor being x minus 4 going into the trinomial. I hate that too. This is a little better too. Not much better, but it's a little better. So we'll use that. Okay, so we have x minus 4 going into x squared plus x minus 12. Sarwan Ansari says your videos are helpful and I got a 100 on my practice Algebra 1 Regents test. That is amazing, Sarwan. 100? You guys make me tear up today, man. Y'all trying to get me to tear up on you guys, all right? Good stuff. I'm so happy that you guys are benefiting from the videos. All right, that means the world to me. I really appreciate that, guys. And always, don't be selfish with this information. If it's helping you guys out so much, share this information with your teachers, with your classmates, with everybody that you know that's in the math class. All right, don't be selfish with it. I'm not being selfish with the things that I know. You know what I'm saying? I'm sharing this freely with the world. I want you guys to also share this information because if you find it helpful to you, that will definitely notify people that you care about and that value your word, that it can help them as well. All right. So there you go. Spread the love, guys. Spread the word. And I appreciate everybody that does that. Let's go ahead and continue with this problem. So we want to find out what we can multiply x by in order to get x squared. We'll be multiplying by x. So x times x is x squared. X times negative 4 is negative 4x. And then we will be changing the signs, guys. All right. So if you need practice on your long division for dividing polynomials using long division, check out my YouTube video. Okay, for Forbidden Tutoring's YouTube video on dividing polynomials using long division and reduction. All right, that's the name of that video, and it'll help you out. So after you distribute, okay, that x times that x minus 4, go ahead and change the signs. All right, let's go ahead and fix this. So that becomes a negative x squared. This becomes a positive 4x. Your x squared terms will cancel out. You'll be bringing down 5x minus 12. Just like that. What's going on, Samuel? That's right. You're my main man, Samuel. How you doing?
I'm doing good. So here we have x going into 5x 5 times. That's going to be a positive 5, guys. So 5 times x gives you 5x. 5 times negative 4 is negative 20. Then what do you do next? You change the signs. That's what you do. And you'll end up with a remainder in this case, guys. And what you need to know, thank you for the link, Angry Herman. And what you need to know as far as finding the oblique equation, the oblique asymptotes equation, is that you care nothing about the remainder. You could care less about it. What you need is the quotient. This right here, that x plus 5. So your equation will be as follows. The equation for your slant asymptote, the oblique asymptote, is going to be y equals x plus 5. This is what you want to give to the teacher. This is what's going to answer that question. This is what you'll find in a red box. That's right. Red boxing it. That's how we roll. That's right. What's going on, Simone? We went over oblique asymptotes as well as graphing rational functions. Derek says when we say the function of x or g or what have you, all we are saying essentially is how does the solution we are solving for fit into the equation? The term function throws me. No. First of all, you're right, Derek. You want to get a grasp on what a function is. A function is basically a group of ordered pairs where the x values do not repeat. That's what you're dealing with. All right. And most of the time you'll find that in the form of a linear function, a linear equation. OK, a quadratic equation, a vertical quadratic equation is going to be what you can call a function. So anytime you have a graph where a vertical line does not hit that graph more than one time, you're dealing with a function. All right. So you can swap out in a lot of cases, Derek, function with the word equation. But basically, you're dealing with equations that do not violate the vertical line test. That's what you're dealing with. So when they're talking about f of x or g of x, more specifically, what you can replace that with, Derek, is the variable y. They're referring to the variable y. So if you see f of x equals to x plus 5, it's the same thing as y equals x plus 5. That's it. All right. Cherished says, I just wanted to thank you because you made my grades go from a 70% to an 87.5. Wow. You went from, in a lot of cases, Cherished, not to put you on blast, you moved from a D to a B. A D as in dog to a B as in boy. You are an awesome person, Cherish, because you put those things that you saw in those videos into practice. And I am so proud of you. Good job. That's right. Tutorial YouTuber said, that's right. Red box your answer and you protect your family. That's right. Protect your family by boxing up your answers in red. That's how you do it. Derek says that he understands. You're welcome. You are welcome, Derek. Let's talk about Babs right now, guys. This problem is all about Babs. Let's check it out. Okay. In problem number 10, it says Babs' boat goes 12 miles per hour. Find the rate of the current of the river if she can go 6 miles upstream in the same amount of time she can go 10 miles downstream. So what we're dealing with in problem number 10 is a distance problem, guys. We are dealing with a distance problem that we will be solving together. Let's go ahead and check that out, all right? Let's go ahead and check out this word problem. Check it out. Well, first of all, for the distance formula, you'll be utilizing the formula distance equals to rate times time. Distance equals to rate times time. And I like to, if you see it already, I like to use a table to set this up. That's what I like to do. Tutorial YouTuber says, okay, I have to go. I don't do Algebra 2, but I will continue to learn with my level. Good job, Tutorial YouTuber. You take care. And so your next level Tutorial YouTuber should be geometry. So you can check out our geometry videos. I'll be uploading some more of those in the near future, sir. So good luck to you. Good luck to you. Good stuff. I appreciate you stopping by and saying thank you. I am saying you're welcome, Tutorial YouTuber. You are very welcome, sir. Good job. All right. So how do we set this up, guys? We're given certain information. We know the boat on its own goes 12 miles per hour, but we are trying to find the rate of the current of the river. And she can go 6 miles upstream. So the distance is 6. And the same time, she can go downstream in 10 miles per hour. So how do we set up this rate, guys? Well, we know the boat is going 12 miles per hour, right? But when you're going upstream, you're going against the current. So that means that whatever that distance, whatever that rate of the current is, it's going to be slowing you down. So going upstream, it'll be our 12 miles per hour for the boat minus the rate of the current. So that'll be 12 minus x. Whereas going downstream, you're going with the current. So the current is helping you along. So that means you'll be going those 12 miles per hour plus that boost that you're getting from the current. Good stuff. Absolutely. So now the only thing missing from my table, because down here I normally have a total amount for this row right here, but for this particular problem I don't need it. So you can go ahead and just blank these out. We won't be needing that for this particular, all right, for this particular problem here, but we do need the time. And so in order to solve for the time, guys, you can take your equation, this formula that we were using, the distance equals to rate times time, and solve for time by dividing both sides by the rate. All right, so I'm dividing both sides by the rate here. Rates will cancel out, so we find that the time is equivalent to the distance divided by the rate. Time is equivalent to the distance divided by the rate. So how does that look in my table? We'll say that my distance 6 will be divided by my rate of 12 minus x. Okay, and that my distance 10 will be divided by my rate 12 plus x. So these are going to be the values of time that I use in this distance problem. Cherished says goodbye, Mr. Witt. All right. And if I could, I would give you a hug. I'm going to hug you right back, Cherished. And you take care. Thank you for stopping by. Continuing on our problem, guys, we have the following. We have our table, and we know that our time is equivalent to one another. They told us that she can go upstream, that Babs can go upstream in her boat in the same time that she can come downstream in her boat, with her going upstream 6 miles versus going downstream 10 miles. So set this time equal to one another, and you'll have 6 divided by 12 minus x equals to 10 divided by 12 plus x. And as I told you earlier, guys, when you have a situation like this, when you have a fraction set equal to another fraction, you can go ahead and cross multiply in order to solve it. So what we'll be doing here is we'll be getting our arrows popping. That's exactly what we'll do. And getting our arrows popping here, guys, we'll have 6 divided by, no, we won't. We're going to get those arrows popping. We're going to have 6 times the quantity of 12 plus x equal to 10 times the quantity of 12 minus x. So this is going to be the equation that I'm able to continue with in order to solve for my rate of the current. Amen, amen. So here we have the distributive property coming. I got my arrows popping. And guys, don't forget to pick up your Get Your Arrows Popping t-shirt on our t-shirt shop for Fort Bend Tutoring. Go ahead and get your own. All right. Arrows Popping t-shirt. We have a link in the description box. Amen, amen. You have 6 times 12. That'll give you 72. Plus 6 times x, which gives you 6x. This equals to 10 times 12, which is 120. Minus 10 times x, which is going to give you 10x there. That 10 times negative x gives you negative 10x. And now we want to isolate the terms with the variable and solve for our variable x here. So how do we go about doing that? We'll be adding 10x to both sides of the equal sign. Yes, we will. I'll be bringing down the 72 plus the 16x, just like so. This equals to 120, canceling out those 10x's on the right side of the equal sign because they're additive inverses. From here, ladies and gentlemen, I'll be subtracting 72 to both sides of the equal sign. Oh, yes, I will. Oh, yes, I will. To get 16x equals to, now, hold on, I got to borrow now. All right, that becomes a 10. 10 minus 2 is an 8. We got the 11 minus the 7 gives you 48. We'll then be dividing both sides by 16, guys. And as it turns out, when you divide both sides of the equation by 16, you end up with your result, which is x equals 48 divided by 16 is 3, guys. And we're using miles per hour, I believe. Yes, we are. We're in miles and we're in hours. So that's going to be miles per hour. That's your unit of measurement. So the current is moving 3 miles per hour, ladies and gentlemen. And we will, of course, red box this answer right here. That's what we're going to do. We're going to red box this answer. This answer is boxed up now. 48 divided by 16, Derek, is 3. 3 times 16 is 48. Amen, amen.
All right. There it is. 3 miles per hour. That's problem number 10, guys.
That was a good problem. That was a word problem.
Word problem, distance problem. That's what's up. Here we have problem number 11, guys. And in problem number 11, we are asked to find the inverse and graph the function and its inverse. We have f of x. Remember, Derek, I said f of x is equivalent to the variable y, right? So you can read that as y equals 2x minus 4. So we have the function f of x equals 2x minus 4, which means we are dealing with a linear function, and they want us to find the inverse of this as well as graph both of them. All right, so that's what we'll do, guys. That's exactly what we'll do. So one thing about inverses and their graphs, guys, the inverse graph is going to be a reflection across the y equals to x line. So let me go ahead and start by showing you guys what I'm talking about. This graph here. All right, let's go ahead and fix that. I think I can do better. Let's do better, Mr. Witt. That this is going to be a reflection across this y equals x line. Let's pretend that's straight. We'll just go ahead and pretend that is straight. That's what we're going to do. Uh-oh. There we go. We're going to pretend that that's straight. There we go. We got our dash line working. Okay. And anytime you're dealing with inverse functions, they're going to be a mirror image across that y equals x line that I just drew. All right. Or attempted to draw, for that matter. All right. But in order to find out the inverse function, okay, what you're going to do is you're going to start out with y equals 2x minus 4. And I think it was Evan earlier that gave me this strategy of replacing f of x with y. You switch out your variables to find the inverse function, and then you solve for y. So that means I'll be adding 4 to both sides. This gives me x plus 4 equals 2y. Then I'll be dividing everything by 2 so that we end up with our inverse function, and we can notate it this way. If I can get my pen to write correctly, here we go, as 1/2 x plus 2. All right, we're saying that the inverse function is going to be 1/2 x plus 2. So let's graph both equations, all right, on our rectangular coordinate system, and we can showcase what this looks like. So let's start out by showing that in, let's use purple for the given function. We know that we have a slope of 2, a y-intercept of -4. So I'll be making my point at -4, and I'll be going up 2 and over 1. Okay? Up 2 and over 1. This is going to give us our graph of the given function. So here we are. Okay. That's that graph. Okay? Then, yeah, that's right, Simone. I put everything into slope-intercept form. And Michael says, I have to go, guys. Mr. Whittington, thank you very much for all the videos you posted thus far. Looking forward to interacting with you again in the near future. Absolutely, Michael. Thank you for stopping by today. I appreciate you. So thank you for stopping by. Guys, so the next thing that I'll be doing is I'll be showing that with the second equation, and we'll go ahead and put that in, we'll put it in black. Okay, that my second equation has a slope of 1/2, and that the y-intercept is going to be 2. So at 2, all right, I start there, and I'm going to go up 1 and over to the right 2, up 1, over to the right 2, up 1, over to the right 2. Same thing here. I can go down 1 and over to the left 2, down 1 and over to the left 2, just getting some points on the line. And over to the right, over to the left 2. There we go. And then connecting these dots here, if I can. Well, oh, no. With your powers combined. There we go. All right. We have our graph. That's what's up. Okay. And notice that this graph, we are dealing with mirror images across the y equals to x line, all right? Because, of course, this is all jacked up, that y equals x line, but that's the way it works. That's the way it works. That y equals to x line going straight up the middle, there are going to be reflections across that line right there. That's what we're looking at. That's right, Simone. Captain Planet in the house. Couldn't help myself. Michael says that it's nearly midnight here in South Africa, and I should be working on my accounting right now. Take care now. No problem, Michael. Take care, sir. get back to work on that accounting. And thank you for spending some time with Mr. Witt and Fort Bend Tutoring. We appreciate it. And of course, the chat is on fire. That's right, with Michael in place. Good stuff. We have problem number 11 completed, guys. Not only
were we able to find the inverse of our given function, which is this right here in red.
This is the inverse of the original function that was given to us. We also were able to graph both of those on the same rectangular coordinate system, and we showed how they were mirror images across the y equals x line. All right, so that's how you can confirm that you're dealing with inverse functions. All right.
Amen, amen, guys. That's how it works. Let's keep things moving here.
Because now we're on problem number 12. And on problem number 12, it says to find the y-intercept of the equation. We have an exponential equation, guys. Y equals 2 times 4 to the x power. So anytime you want to find the y-intercept of an equation, all you have to do is plug in 0 for x and solve for y. So we're going to replace our variable x with 0 and simplify this in order to find the y-intercept.
So this becomes 2 times 4 to the 0 power, guys, is 1.
Yeah, anything to the 0 power is just going to be 1, except for 0 to the 0 power. You know, that's indeterminate. It's undefined. However, 4 to the 0 power, that equals to 1 all day long.
So therefore, 2 times 1 gives you 2.
Yeah, it's over.
It's over. However, guys, keep in mind that
depending on the author of the test that you're taking, all right, aka your teacher, they may want you to write the y-intercept as an ordered pair. So if they're asking you for the y-intercept as an ordered pair, then you're going to write it as 0, 2. Just like that. So be aware. It depends on the question, the way the question is worded. Okay. If you're dealing with a multiple choice test, look for either of these. Okay. So they just could say straight up that the y-intercept is 2. They could say that. Or they could give you an ordered pair, and note that the ordered pair must be in the form of 0, 2. Anytime you're dealing with a y-intercept, the x value will always be 0. Oh, yeah. So keep that in mind as you do your Algebra 2 final exam, second semester, end of course exam. There you go. That's problem number 12. We're moving on. Yeah. And this is just a reminder, guys, for you to subscribe to Fort Bend Tutoring's YouTube channel. That's right. Go ahead and click on that subscribe button. Also, if you want to be notified in the near future as to when we're going live with information, also when we are posting new information, go ahead and click on that bell icon right next to that subscription box. Right next to the subscription button, click that bell icon. All right. So let's help this channel grow so that we can reach more people, including you, on a regular basis with more math tutorials from me, Mr. Witt, and Fort Bend Tutoring. So go ahead and subscribe to Fort Bend Tutoring, ladies and gentlemen, and let's move on to our next problem, which is problem number 13. Amen, amen. That's right. So here in problem number 13, guys, they are asking us to evaluate log base 2 of 8. And anytime you want to solve a problem like this, what you can do, all right, so for starters, I'm just going to rewrite the problem. Okay, so we have log base 2 of 8 is you can rewrite the number 8 in terms of base 2. That's right. Say we got another logarithm in place. So we have log base 2 of 2 to the third power, because I know that 2 to the third power, in other words, 2 times 2 times 2 is equivalent to 8. Yeah, it's equivalent to 8. So therefore, the log base 2 of 2 and 2, these will cancel out according to your logarithmic properties. And so that your answer here is 3. That's it. So what we're going to do is realize that the driving force of this problem is the base that it's referring to. So when they say log base 2, you need to know that the base that they're referring to, the base that they care about the most, is the number 2. So if you're able to rewrite the number 8 in terms of the base, then it will help you simplify the problem even faster. So what I was able to realize is that, oh, that 8 could be rewritten as 2 cubed. In other words, 2 times 2 times 2 is 8, because 2 times 2 is 4, and then 4 times 2 is 8. So I knew that 2 to the third power is 8. Once I do that, that will simplify with our given logarithm and leave you the exponent as your result. So the answer is 3. Good job. Saya is co-signing on that to say that that answer for problem number 13 is correct.
Thank you so much, Saya. Appreciate you co-signing that answer there.
That's right, Simone. I already hear it in your head. Go ahead and brush up on those logarithms if you want to be down with those. Amen, amen. Here we have, guys, problem number 14. We have solved the equation and check for extraneous solutions. Remember, guys, I told you before that when you have equations, when you have rational equations, when you have the variable in any of your denominators, that leaves an open situation for you to have extraneous solutions. What do I mean by that? That you can solve for the equation algebraically correct. However, your end result could not be a part of the domain, that it could not be a valid solution because it creates a zero in your original denominators. Okay, so you can never have zero in the denominators of your fractions. You can't have that. That's right, Simone. I read mines part-time. Yeah, it's not a new thing. It's just new to you. But I've been reading mines for quite some time now. It's okay, Simone. You're in a safe place. I'll never use the information that I get out of your head for any wrongdoings. Okay, so you're in a safe place here. Let's go ahead and cross multiply. I'm just kidding, guys. I don't read minds. I just read minds. we're going to cross multiply here. I'm gonna let you guys let that marinate on you for a little bit. I'm cross multiplying. That's what I'm doing. I got my arrows popping. Okay, y'all over here playing games, and I'm over here playing games. I don't even think I'm making sense at this point. Hey, guess what I noticed, guys? That both sides of the equal sign, here is divisible by 6. Let's just go ahead and simplify this. All right, let's do this, because I could get my arrows popping, and I would be happy about that. I really would. But I'm even happier about simplifying this equation, so I don't have to deal with big numbers unnecessarily. So because both sides of the equal sign was divisible by 6, I just simplified everything by 6. I mean, that's how we rolling today. That's how we are rolling today. Thank you. Okay, let's bring down this v plus 2. Let's get this v on. Okay, and on the right side is v squared minus 4. Just having fun with my peeps today, guys. Where we are going to review for this Algebra 2 final exam review. Part 1, guys, by the way. Part 1. Part 2 is coming soon. That's right. Part 2 is coming soon. Hey, guys, check out how I'm subtracting v to both sides and subtracting 2 to both sides in order to set this equation equal to 0. Be aware that these v's are not like terms, so you're going to have to sit them side by side. So I have v squared minus v minus 6 equals 0. That's what I'm working with right now. You see that? You see how that worked? Now I'm going to be factoring, if this is factorable, and I believe it is. We're looking for 2 factors of 6 that subtract to give us 1. That'll be 3 and 2, right? So I can rewrite this as v minus 3 times v plus 2 equals 0. Notice how many problems that we've seen that we had to factor a quadratic trinomial, guys. So if you need assistance with factoring quadratic trinomials, check out our YouTube video called Factoring Quadratic Trinomials Part 1 and Part 2. You want to check out those as well. But check out Factoring Quadratic Trinomials Part 1, as that'll help you factor these quadratic trinomials that you'll see quite a bit of on your Algebra 2 final exam review. Amen, amen. Now, using the zero factor property, we'll be setting each of these factors equal to 0 and solving for it. So I have v minus 3 equal to 0. I got my, oh Lord, was that supposed to be a v? I think that was supposed to be a v there. All right, so I have each factor set equal to 0, guys. I'm going to then solve for v in each of these, and then this will give us our potential solutions. Remember, I'm saying potential solutions because these can't be taken as real solutions if it violates any of the denominators of the original problem. For instance, if we plug in 3 into the original problem, we do not generate a 0 in any of these denominators, right? So that's a good answer. 3 is good to go. We're happy with 3. All right, that's a good check mark. There we go. But plugging in -2, guys, is going to be a no-go. We can't use -2. Why? Because -2 squared is 4, and 4 minus 4 is 0. And over here to the right, if we plugged in -2 here, -2 plus 2 is 0. So -2, guys, is an extraneous solution. We can't use this. Therefore, the only solution to our problem is the number 3. Okay, trying to get my brace on. Okay, that's a decent brace. Oh, that's an ugly 3. That's an ugly 3. That's a better 3.
That's an ugly brace. That's an ugly brace. That's an ugly brace. That's an ugly brace. I'm going to have to deal with that. Okay. We're going to red box it.
And done. Yeah, there we go. Finally, guys. So basically, when I'm doing my studio videos, I'm cutting out all those quadrillion times that I can't draw a brace. That's right, Simone. It's not going to be helped out. Say it says, you think Howie is so master at math because he can read Terry Tao mind? Oh, say you and your jokes. You and your jokes, sir.
We're moving on to our next problem.
I got my answer in the box. What you working with? No. Simone says that there is video evidence that I do know how to draw a brace, and my rebuttal to Simone, guys, in your presence is the following. Simone has verifiable proof of me being lucky at drawing braces. That's what you have proof of, ma'am. Me being lucky. Derek says 0 in the denominator is undefined. That is correct, Derek. You cannot divide by 0. You can have 0 in the numerator of a fraction, but never in the denominator of a fraction, Derek. And I'm thanking you for asking me that question, because that's going to help you solve a whole lot of problems in the near future, sir. You need to know that 0 in the denominator is a never good thing. Never is it a good thing. All right, so we have problem number 15, guys, where they want us to find the distance between point A as well as the distance between point A and C. All right, and that's why the -2 won't work. That is correct, Derek. That's why we didn't accept the -2, because it created an undefined situation. Can't take that. Can't have it. And that is called an undefined situation, an extraneous solution, a solution that won't work in the original problem because it creates a 0 in the denominator. You're asking great questions, Derek. All right, so let me reread 15 because I think my mouth wasn't working at the time. It's probably because I need to drink some water. I'm going to drink some water right now. That's right. I like Ozarka. It has a little sweet taste to it. I hate Dasani and Aquafina. They taste like crap. Yeah, I'm so team Ozarka as far as the bottled water is concerned. And I know y'all gonna probably hit me up with that Fiji water and all that other kind of stuff, all that expensive crap. Ozarka is where it's at. Thank you. Then find the midpoint of AC. That's right, Simone. No orange juice today. I had to cut down on my sweets, man. I'm drinking too. I have my sweet content was way high. All right, so I need some water to flush it out. So here we got point A and point C. They also want us to find the midpoint, guys. So this is two different problems in one. All right.
If you're going to find the distance between these 2 points, you'll be using the distance formula. Distance is equivalent to the square root of x2 minus x1 squared plus y2 minus y1 squared. There we go.
That's what we got. And we'll go about the business of labeling these points first. So I'm labeling point A as x1, y1. I'm labeling point C as x2, y2, like so. And then we're going to be plugging in these values and simplifying this. All right, so that's what we got going on.
So for starters here, we have the following. We have the square root, all right, of 2 minus x1, which is 9, squared, plus y2, which is 2. Hey, that wasn't x2. Let me fix this, guys. Get my lie together. My x2 value is -7. Better. So this is -7 minus 9. That's correct now. Now my y2 value is 2 minus my y1 value, which is 6. And that's going to be squared.
There we go. Better. It's better now. Thank you.
And now, simplifying this even further,
we have the following.
We have -16 squared plus -4 squared. Well, guys, this gives us the square root of 256 plus 16.
That's what. Oh my God, y'all cannot see that. Let me fix it. Here you go. Now you can see it. So the -16 squared is 256. The -4 squared is 16.
And now we'll be adding that together. All right. And does that give us the square root is 272, guys?
Is that right? Square root of 272? Yeah, I think that's right. And with this being square root of 262, that means that we have
the following expression that we can write in hopes of simplifying this. We could expand this to be 16 times 17.
And then taking the square root of 16, you'll end up with your final answer being 4 times the square root of 17. There you go. This is going to be the distance between point A and point C. Absolutely. Yeah. So we end up with 4 times the square root of 4 times the square root of 17. Amen. Saya says he did it with a calculator. I know you did when you came up with that ugly decimal. Saya, I already knew. You didn't have to tell me you use a calculator. Oh, I knew what you did. Let's go ahead and have me use my calculator to verify this before I move on. All right. Yes, sir. I agree with you. That is the correct answer, sir. Done and done. That's it. Now, that's just part 1. That's just part A of this problem, because notice they wanted us to do 2 things. They wanted us to find the distance between that point, as well as between those 2 points, as well as find the midpoint. All right. So let's go ahead and duplicate this page here. Let's do some stuff on the fly, guys. Let's hook this up. No. We don't want to do that. Let's go ahead and hook this up real quick. Let's go ahead and duplicate that. Right. There we go. Let's go ahead and go to this page. Let's go ahead and erase all what we just did. Let's erase this. Don't worry. We still got it. We still got it, but we're going to erase this, because what we're going to get ready for now is finding that midpoint. Right. So notice how cool I am, guys, because I accidentally did this. I know that this right now I'm having a nerd moment, because I'm just realizing me erasing that square root sign left me with the problem that I'm about to do underlined. Find the midpoint of AC. I'm excited about this because that wasn't even on purpose. That I have find the midpoint of AC, which is what I'm about to do now. Already underlined because I need to do that. So thank you. I'm just having my own moment here. I don't even care if you guys like what I just did or not, because I'm excited for myself. Okay? There you go. That's what's up. Me is happy. That's right. Happy me. Okay? See, let's just say that this right here is my face. And my face is smiling right now. Thanks, Saya. So here, because Saya has his smiley face too. He's working with his smiley face right now. All right. As far as the midpoint formula is concerned, guys, the midpoint formula is going to be x1 plus x2 divided by 2. We'll have y1 plus y2 divided by 2. All right. So that's what we're working with right now. And now that we have this, we already have our point A and point C labeled, right? We'll go ahead and plug in these values here in order to find out our midpoint. So therefore, the x1 value is 9. We'll have plus the x2 value, which is -7, all over 2. And this is going to be within parentheses because it's an ordered pair. Then we'll have y1, which is 6, plus our y2 value, which is 2, divided by 2. There we go. There we go. So going further, if you would combine these two signs here, that's equivalent to 9 minus 7 divided by 2. We still have our 6 plus 2 divided by 2. And then 9 minus 2 is 2, guys. So that's 2 over 2. And then 8 divided by 2. So your final answer here. All right, let's go ahead and hook this up. Hook this up. There we go. So our final answer here is going to be the following. The final answer is going to be, let's go ahead and fix this. Final answer is going to be 1, 4. That's what we got. 1, 4 is the midpoint. And we're going to red box it. And Simone says that I didn't red box the first part of the answer. Let's go ahead and make sure we get that done. That first part of the answer was going to be 4 times the square root of 17. So therefore, we need to red box that as well. There you go, Simone. There's the red box for that first one. Thank you for keeping me honest, Simone, as always. Appreciate you keeping me honest with the red boxing. For part A was finding the distance between point A and point C. And then the second part of this problem was to find the midpoint of AC, and we did that as well. So notice that you have two different formulas for finding the distance between points, whereas finding the midpoint between 2 points, all right? And we did both in problem number 15, and we're now moving on to problem number 16, guys, as we are asked to find the center and radius of problem number 16. And in order to do that, we're going to use the completing the square process to get this done. We're going to put this in standard form of a circle, guys. We're dealing with a circle. If they're asking us for the center and the radius, you know you got it. You know they're asking. You know they talk about a circle, right? They're talking about a circle. Yeah. And so we'll be putting this in the form x minus h squared plus y minus k squared. Let me get my lie right. Y minus k squared equals r squared, where the center is hk. There you go. There you go. So we'll be putting this equation in this standard form, aka the center radius form, for a circle. That's right. And we're going to do that using the completing the square process. So check me out. The first thing I want to do, guys, is I'm going to group together the x terms. So I have x squared minus 4x. I'm going to put a blank. Plus y squared plus 4y. I'm going to put a blank. And then let's go ahead and add 17 to both sides. So let me go ahead and hook that up for you. Let me go ahead and show, because I don't want anybody missing out on a step here because I didn't have room. Let's go ahead and bring that down a little bit. There we go. All right, we're going to bring that down. We're going to bring it to, yeah, we're going to put it over here. We're going to put the standard form over here, guys. There we go. We just moved that out the way. And so our first step here, and me getting my lie right, is to add 17 to both sides of the equal sign. Let's do that first. How about that? See? We can fix things on the fly. We can fix things on the fly. There we go. Better. This is much better now. So, over here to the right, upper right, I'm showing you where I'm going. Yeah, that's the standard form of a circle, aka the center radius form. And what I did with my given equation is I started out by isolating the terms with the variables by adding 17 to both sides of the equal sign. I did that first, and now I'm putting those x terms together with a blank, the y terms together with a blank, and on the right side of the equal sign I have 17. Let's get the ink going. I got 17 blank blank. There we go. All right. So in order to complete the square here, you'll be taking half of the middle term's coefficient and then squaring that value. So half of negative 4 is negative 2, and negative 2 squared is 4. So that goes in this first blank on both sides of the equal sign. That's what's going on. Then, when it comes to the y terms here, I'm going to take half of the 4, which is 2, and then I'll be squaring the 2. So 2 squared is positive 4. So I'm adding 4 here as well. How about that? You see? And now that we've just finished completing the square to create two perfect square trinomials, go ahead and factor that. And when you're factoring a perfect square trinomial, know that you're going to use the variable, that variable x, in this case for the first one, and whatever half of that middle term's coefficient was, we'll end up with the following factorization. You'll have x minus 2 squared plus y plus 2 squared. Oh, I'm hating these plus signs here. The plus signs were ugly. There we go, because this plus sign is ugly. We're going to fix this ugliness. And this is going to equal to 25. It's going to equal to 25 on the right side of the equal sign. There we go. There we go. And now what you do is the following, guys. To identify the center, you just use the opposite signs of those values within the parentheses. So the center is going to be 2, negative 2, with a radius that will be the square root of 25. And the square root of 25, guys, is 5. And so this completes the answer to question problem 16. There you go. There you go. We have a center of 2, negative 2, and our radius is 5 units long. That's exactly what we have for problem number 16, ladies and gentlemen. Problem number 16 is complete. That's right. Done and done. And we use completing the square. Saya says nice, nice. That's right, Saya. It is nice, nice. Saya. That's exactly what it is. All right. So let's go ahead and move on to our next problem. Problem number 17 is in effect, guys. Here we go with problem number 17. What you doing? What you doing with problem number 17? It says solve by factoring. Solve by factoring. So they want us to use the zero factor property in order to solve this problem. That's what they want us to do. And that's exactly what we will do. So let's make this happen, guys. All right. So in solving this problem, we'll be starting out by subtracting 34x squared to both sides of the equal sign, like so. Thank you. We now have this rewritten as 8x cubed minus 34x squared plus 30x equals 0. And the first thing I'm going to do is I'm going to factor out the GCF of this problem. And in this case, the GCF, the greatest common factor in this problem, ladies and gentlemen, is going to be 2x. Let's factor out that 2x. You'll end up with 4x squared minus 17x plus 15 equals 0. That's exactly what we're doing here. Then, in continuing to factor this, all right, check out my flow as I utilize the techniques that I show in Factoring Quadratic Trinomials Part 2. All right, Factoring Quadratic Trinomials Part 2 is going to help me with this process. You're going to start by multiplying the first coefficient within the parentheses times the last one. In other words, 4 times 15 gives me 60. I know that factors of 60 are 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. I'm looking for 2 factors of 60, guys and gals, that will add to give me 17. 2 factors of 60 that will add to give me 17. Well, those 2 factors, guys, are going to be 5 and 12, right? Yeah. Now, mind you, be careful that you don't choose the 3 and the 20, because we know that 20 minus 3 is also 17, right? But the last sign of the trinomial tells you what operation you need to do. So because that last sign of the trinomial was a plus sign, a positive sign, that means that you need to add. That's right. You need to add those factors to get the middle term's coefficient. That's what you need to do there. All right. So we choose the 5 and the 12 that will add to 17 versus the 3 and the 20 that would have subtracted to give us 17. And they're not interchangeable, guys. If you choose the wrong one, you will get it wrong. So you had to know that the factors of 60 had to add to give you the 17, which is why we must use the 12 and the 5. So go ahead and put your variables into the parentheses there. We'll use the 12 and the 5. It needs to be a negative sign. That 12 needs to be negative because that's the sign of the largest factor, the middle term coefficient. The sign on the middle term's coefficient will always be the sign of the largest factor. Because you're adding to get 17, the 5 needs to also be negative. But we will not forget that leading coefficient is 4. So we will now simplify both of these values by 4. All right. So in doing that, we'll be bringing down the 2x times x minus 3. And because 5 and 4 can't be reduced any further, place that in front of the variable x to give you 4x minus 5. And this equals 0. Amen, amen. Cherish is back now. Welcome back, Cherish. Welcome back. So now that everything is completely factored at this point, in other words, multiplying all of these factors together will give you back your original equation of 8x cubed minus 34x squared plus 30x equals 0. We will set each factor that contains your variable x equal to 0 and solve for it. Okay, so we'll set each factor equal to 0 and then we will solve for it. Amen, amen. All right. Saya says, welcome back, Pikachu. So we have 2x equals 0. We have x minus 3 equals 0. We also have 4x minus 5 equals 0. And we will solve for x in each of these equations here. In the first one, I'll be dividing both sides by 2. That gives me x equals 0, guys. In the second one, we'll be adding 3 to both sides. I have x equals to 3. We will then add 5 to both sides of the equal sign in that last equation, and then divide both sides of the equation by 4. So once we've done all of that, we end up with our solutions of the equation, which will be the following. Let me see if I can get a good brace going, guys. We have 0, 5/4, and 3 as solutions to problem number 17. 0, 5/4, and 3 is what we have as a result. Amen, amen. That was problem number 17. That's right, Derrick. You have the answer correct. 0, 3, and 5/4 And as a math student, you will want to learn to start writing your answer in ascending order as though you would see it on a number line. All right. So as long as you see your answer choice there, I'm sure you would get that answer correct there, Derek. But just in general, it's not that it makes it incorrect. It's just proper to write your answer in a solution set in ascending order as though you would see it on a number line. Amen. Amen. We are now looking at problem number 18, guys, as we're asked to simplify the following problem. We have the square root of 18 plus 2 times the square root of 50 plus the square root of 98. And so when you want to simplify these type of problems, guys, you want to start out by looking for the index of the radicals that you're dealing with. So in other words, I know that the index of each of these square root signs is 2. So I'm looking for perfect squares, in other words. And I'm going to use those perfect squares within these values to help me simplify them. All right. And hopefully I'll be able to add them and subtract them according to the expression, because you need to know that in order to add and subtract square roots, you got to have, or radicals for that factor, for that matter, you need to have the exact same radicands underneath the symbols there for the square root signs or the radicals. All right. So let's start by simplifying here. I'm going to span 18 by showing that this is equivalent to the square root of 9 times 2. So what I'm doing here, guys, is I'm showing you the largest perfect square that is also a factor of 18. Then I'll be doing that to each of the other radicals here. So I'll have 2 times the square root of 25 times 2, because 25 is the largest factor of 50 that is also a perfect square. Continuing on with that last square root sign, we have the square root of 98, but I'm going to change this into the square root of 49 times 2, because 49 is the largest perfect square that is also a factor of 98. Once I've done this, I'm going to then take the square root of these perfect squares underneath the square root signs and multiply them times the coefficients that we have on the outside of the radicals. Okay, so for instance, I have 1 times the square root of 9 times 2, but if I take the square root of 9, which is 3, I'll multiply it times that coefficient of 1 to get 3 times the square root of 2. All right, taking the square root of 25, we'll have 5 times 2. I'll show this step here. Times the square root of 2, and then minus the square root of 49 is 7 times the square root of 2. So this is what we have so far. So Derek is saying, ooh, all right, as I'm showing him some good stuff here. Then we'll have 3 times the square root of 2 plus 10 times the square root of 2 minus 7 times the square root of 2. And once we have all of that, we can finally start combining these like terms. Remember, you don't have like terms with radicals until the radicands are identical to one another. So these all are like terms at this step because they all have the square root of 2. And because they all have the square root of 2, I can combine them. So let's start out with the first 2 terms. We'll have 3 plus 10. That gives us 13 times the square root of 2 minus 7 times the square root of 2. And then following that up, we'll have 13 square root of 2 minus 7 times the square root of 2 to give you 6 times the square root of 2. And we will red box it, ladies and gentlemen. There you go. So this original mess was able to be simplified to 6 times the square root of 2. And isn't that cute in a red box? I'm moving on. Problem number 19 coming up. All right. But first, guys, we want to remind you, and I want to remind you, that you can set up a paid online tutorial with me, Mr. Witt, with Fort Bend Tutoring at tutormemath.net. That's right. tutormemath.net. There you go. All right. So, that's right. And also, guys, Say was saying that I have a method posted on my YouTube channel as far as finding the square roots, estimating the square roots of numbers, and there is a link for that. That's right. It's called Estimating Square Roots to the Nearest Tenth by Hand. Is another way to find out the square roots of numbers by hand without using a calculator. There you go. There you go. Yeah, you go. So there you go. Just wanted to remind you guys that I am available to help you out one-on-one. And now we're on problem number 19, guys. Problem number 19. We're on our last set of numbers as we will be finishing up with problem number 24 today, guys. We'll be finishing up with problem number 24 today. Let's get things done. Let's get things on and cracking with the problem number 19 that you see before you right now. We have to simplify this, guys. Thank you very much for that link, Saya. We have the quantity of the square root of 7 minus the square root of 2 squared, guys. So we are going to expand this. We'll have the square root of 7. We'll have the square root of 7 minus the square root of 2 times the square root of 7 minus the square root of 2. That's exactly what we're working with right now, guys. And we're going to get our arrows popping here. That's exactly what's going on. And we have the square root of 7 times the square root of 7, guys. That gives us 7. Then we have the square root of 7 times a negative square root of 2. That gives us a negative square root of 14. From here, we'll have a negative square root of 2 times square root of 7 to give us another negative square root of 14. And then we have a negative square root of 2 times a negative square root of 2 to give us a positive 2. Done and done as far as the multiplication is concerned. And notice, guys, that I got my arrows popping, which means that I'm using the distributive property. My favorite property, by the way. Thank you. Just saying. From here, we're going to be combining our like terms. We know that 7 and 2 will combine to give us 9. And combining negative square root of 14 and negative square root of 14 will give you negative 2 square root of 14. And done. Go ahead and put a red box around that. Go ahead and put a red box around that answer. Thank you so much. Appreciate that. That's problem number 19, guys. It's over. It's over. I put it in the red box. You know it's over when I put it in the red box. Okay? You already know it's over. In problem number 20, we are dealing with complex numbers and the multiplication of them. That's right. We're dealing with imaginary numbers in this problem, guys. They want us to simplify this. And there's a couple of things that you need to know. So let me go ahead and highlight those real quickly for you. You need to know that the imaginary number I is equivalent to the square root of negative 1. You should know that. Thank you. Then, that's right, Simone. The distributive property has finally defeated factoring only by a hair, Simone, because I love factoring. Okay, but I think those arrows popping has gone ahead and pushed it over the edge. Absolutely. So as far as the notes that you need for this problem, guys, you need to know, first of all, that the value I, the imaginary number I, is equivalent to the square root of negative 1. You also need to know that I squared is equal to negative 1, that I squared equals to negative 1. You need to know that. You also need to know that your answers need to be written in standard form of a complex number, which is A plus BI format. In other words, you'll put the real number before the imaginary number. All right, you will put the real number in front of the imaginary number. That's RECIP. All right. So Simone says, do they pop like pop rocks? Absolutely they do, Simone. They definitely pop like pop rocks. What's going on, Cherish? All right, so here we go. So now we are going to go ahead and distribute this by getting our arrows popping. That's exactly what we'll do. So we'll have 2 plus 3i times 1 minus 5i, and we will get our arrows popping up in this piece. That's exactly what we'll do. All right, so I got my arrows popping here, guys. We have 2 times 1 is going to give me 2. 2 times negative 5i is negative 10i. 3i times 1 is positive 3i. We have 3i times negative 5i. That gives you negative 15i squared. Then we'll go ahead and bring down that 2. Combining your like terms, you get negative 7i. And you'll have negative 15. And notice I said earlier that I squared is equivalent to negative 1. So we'll go ahead and replace that I squared with negative 1. Amen, amen. All right. From here, guys, we'll be combining our like terms. We not combining our like terms, but doing that multiplication there. We'll have 2 minus 7i plus 15. And then finally, remember, you're going to be writing your real number before the imaginary number. You'll write it as 17 minus 7i, and we'll be red boxing the answer. That's right. Yeah. Done and done. Simone says it was a long battle, Saya, but his arrows do pop like pop rocks. You can hear the passion. Absolutely. Good stuff, guys. We have 4 more problems, and then we're wrapping things up, guys. So let's get through them quickly. Next up, we have problem number 21.
Problem number 21.
We have to describe the end behavior of each function. Describe the end behavior of each function. We have f of x equals to negative x squared plus 4x minus 1. Derek says, why is I square equal to a negative 1? All right. Let's answer this question for Derek real quick, guys. All right. Since Derek is here with us. If we know that I equals to the square, if we say let I equal to the square root of negative 1, Derek, then if I square that I, all right, there we go. Then what happens when we know that our index here is 2 for the square root, right? Well, the square root and the square will cancel out to leave you with negative 1. All right. So if I say that I equals to the square root of negative 1 and then I square that, well, that takes care of that square root sign. And what's left underneath is the radicand, which in this case is negative 1. So I squared would be equivalent to negative 1 because of that. So starting out, we said that I was equal to the square root of negative 1. And so therefore, if I square this value, you know that whatever is underneath that square root sign comes out. So squaring that square root of negative 1 leaves you with negative 1 when you square the variable, when you square that value, that imaginary number I. That's what's up. Okay. So that's all that's done, Derek. Thank you for that question, sir. Keep them coming. Keep them coming, Derek. Now, number 21. Is talking about describing the end behavior of each function. So this function is negative x squared plus 4x minus 1. Well, you need to know, guys, that the parent function involved in this is y equals x squared. Well, y equals x squared is the vertical parabola. And so a sketch of that, remember I said I hated sketches earlier, right? But it looks like this, all right, the vertical parabola on the graph, okay?
Well, that means that because of that negative in front of it, it would point down.
So it's reflected across the x-axis. So when it's describing the end behavior, they're saying
what happens, guys, here and here
on the ends. They are literally saying what happens on the ends of these graphs. That's what they want to know when they say describe the end behavior.
So when you're answering this question, you're going to say that, and you can just wrap it up like this in most tests. You can say that it falls to the left, and that it rises to the right.
Okay, so you can say that. That's one way to describe this.
That it falls to the left and it not rises, guys, and it falls to the right. It's falling on both sides. Okay,
so that it falls to the left and it falls to the right.
However, you can also say that as f of x approaches negative infinity, that I'm sorry. Let me fix this. We could say that as x approaches negative infinity, f of x, okay, will also approach negative infinity. So we're saying that as your x's get smaller and smaller, in other words, as it moves to the left of the graph, that your y values will also go to negative infinity as well. That it will, in other words, fall to the left. But as x approaches positive infinity, in other words, as your x values increase, your y values will also still go to negative infinity. All right. So looking at this graph here, as we move along to the left on the graph, it's falling down. All right. It's going further and further, getting smaller and smaller, so that value is going to negative infinity. But it also occurs on the right. Okay. So as you move to positive infinity, it's going to still go to negative infinity. In other words, those y values will go to negative infinity as well. There you go. So negative frowns and positive smiles. That's correct, Simone. You can sum it up like that. You could sum it up like that, and that will give you your answer for this problem. Let's go ahead and red box it. All right. So depending on your test, it could say falls left, falls right, or they could get fancy and say that as x approaches negative infinity, f of x approaches negative infinity, and as x approaches positive infinity, f of x approaches negative infinity.
That's right, Simone. One side can fall while one rises. Those are cubic functions. So to answer Simone's question, guys, real quick, if you had a function that was f of x equals to x cubed, Simone, the graph of this, all right, looks like this. Boom. All right. So therefore, it would fall to the left and rise to the right. So it's possible depending on the function that you're dealing with. Great question, Simone. All right, let's move on to our next problem, guys. Problem number 22. So in problem number 22, we are to simplify the following problem. Let me get it in view for you. We have the quantity of 2x to the negative fourth power b to the 0 power divided by a to the 0 power b cubed, all squared. And because of that square, we're going to realize, first of all, I'm going to simplify within this, guys. And I told you earlier that anything to the 0 power other than 0 will equal to 1, right? So we can reduce this to 2x to the negative fourth power over b to the third power, because b to the 0 power is 1 and a to the 0 power is 1. All right, so that can simplify in that way to start. Then realize that 2 is to the first power, and every element within this rational expression will be squared. All right, so you'll be multiplying the exponents by 2 because you have a monomial raised to a power. And anytime you have a situation like this, the exponents will be multiplied together. So you'll have 2 squared x to the negative 8th power all over b to the 6th power. From here, you want to eliminate your negative exponents by shifting the base to the opposite location in the fraction. In other words, if you have a base with a negative exponent in the numerator, go ahead and shift it down to change the sign on the exponent. And if you have a base in the denominator with a negative exponent, you shift it up to change the sign on that exponent. All right, so you'll end up with 4 over b to the 6th power x to the 8th power. And that's it. Yeah, that's the answer. There you go. Eduardo says that he got the answer the long way. No problem, Eduardo, as long as you get the answer. But if you need to be aware of how much time you're spending during a test, then definitely check out some of the strategies I provide, because I try to be as efficient as possible, Eduardo. In other words, I don't like to waste too much time. I know you guys have a short amount of time to take your exams. So if you can pick up on the strategy and the technique that I use to solve that problem, then that should be able to help you as far as being efficient, time efficient during your exam. All right. So good job on getting the right answer, nonetheless. All right. So here we go, guys. We have problem number 23. Problem number 23, we want to factor each completely by grouping. So notice that we have 4 terms. We have 8k cubed minus 7k squared minus 32k plus 28. And we want to factor completely. Well, let's go ahead and group the first 2 terms together. All right, in an attempt to factor this by grouping. You want to always put a plus sign between the second and third term, guys, no matter what. So notice that even though my third term was negative, I put a plus sign between them, and I included that negative within the parentheses of that second group. All right. Out of the first group, we can factor out k. That leaves me with 8k squared minus 7k. Oh, no. Hold on, guys. Let me get my lie together. We can factor out k squared. Sorry about that. Factor out the k squared. That leaves you with 8k minus 7. That's what I meant to say. Sorry about that. Then in the second group, you'll be able to factor out a negative 4. And actually, guys, make sure that because that first term is negative, you know that you'll need to factor out a negative something. In this case, I know to factor out a negative 4. So that leaves me with 8k minus 7 in that second group. Because we now have 2 terms, guys, because terms are separated by a minus or plus sign, we have 2 terms at this point. These 2 terms have 8k minus 7 in common. So factor out that GCF of 8k minus 7, and that leaves you with k squared minus 4 for the second set of parentheses that you'll open up. However, you are not done factoring. And the reason why you're not done factoring at this point is
because in that second set of parentheses,
we have what is called a difference of squares. And this difference of squares is factorable.
So you'll be bringing down that 8k minus 7, opening up two sets of parentheses where you'll take the square root of k squared, which is k, and taking the square root of 4, which is 2. And because I'm an optimist,
I like to put my plus sign before the minus sign, guys.
So this completes the factorization of problem
number 23 in a red box. There you go. Amen, amen, ladies and gentlemen. We have the quantity of 8k minus 7 times the quantity of k plus 2 times the quantity of k minus 2. There it is. There it is. Saya says, Mr. Witt, what comes after algebra? If you're in high school, Saya, after algebra 1 comes geometry. After geometry comes algebra 2. After algebra 2 comes pre-calculus. After pre-calculus comes calculus 1. There you go. There you go. If you're in college, you would start out with college algebra, which is practically this class right now that we're reviewing for now. And then after that, depending on your track, if it's a science track, then you would most likely move on from college algebra to pre-calculus, which would include trigonometry. And then you would move on from pre-calculus to calculus. All right. There you go. So I hope that helps. Saya says thanks. So that must mean that it helped. Good stuff. Let's move on, guys, to our next problem where we're asked to divide using polynomial long division. All right. And I think we referenced this earlier today. So we have another example of dividing polynomials in problem number 24. So my divisor here, guys, is going to be b plus 6. That's going to go into b cubed plus 2b squared minus 14b plus 60. You want to make sure that you are writing down each term in descending order of the variable. So start with the term with the highest exponent and work your way down. Make sure that you have any missing terms shown. So for instance, if they would have missed out on that b to the first power term, I would have put 0b in that as that dividend, okay, within that, as that dividend, to make sure that I have it presented. That's right, Simone. Simone says, so that's the order. Absolutely. So you want to go down 3, 2, 1, and none. All right. So Simone is one. Oh, so Simone says that's the order. Maybe you're referring to the math classes. All right. Understood. So let's focus on that first term here, guys. Focusing on the first term here, we want to say, what can we multiply b by in order to get b cubed? Well, in that case, you'll want to multiply by b squared. So distribute that b squared to your divisor of b plus 6 to end up with b squared times b, which is b cubed. You'll have b squared times 6, which is going to be 6b squared. And then you want to change the signs, ladies and gentlemen. And in changing the signs, that becomes a negative b cubed. That becomes a negative 6b squared. Your b cubes cancel out. 2b squared minus 6b squared leaves you with a negative 4b squared. And you'll bring down that negative 14b at that point. Amen, amen. From here, you'll do the following. You'll be multiplying b times negative 4b in order to get that negative 4b squared. So distribute, so you'll have negative 4b times b, that gives you negative 4b squared. Then multiplying negative 4b times 6, that gives you negative 24b, like so. And after you distribute, you must change the signs. Go ahead and change those signs at this point, guys. Remember that you can see more examples like this on our YouTube video, Dividing Polynomials, Reduction and Long Division. Amen, amen. From here, guys, we'll do the following now. We'll have the 14b plus the 24b. That leaves us with 10b plus 60 at this point. We have 10b plus 60. So we'll be multiplying b by 10. Oh, yeah. So distribute that 10, and you'll have 10 times b, which is 10b, of course. You'll have 10 times 6, which is 60, of course. And then you'll be changing the signs. That's right. Change the signs after you distribute every time. The 10b's cancel out. The 60's cancel out. So this terminates at 0. That means it's over now because it equals 0, all right, with no remainder here. And that means that your solution here, your quotient, is b squared minus 4b plus 10 Amen. Amen. Ladies and gentlemen, it has been a pleasure working with you today. I want you guys to realize that I want you to subscribe to Fort Bend Tutoring. Go ahead and do me a favor. Do the Fort Bend Tutoring a favor by subscribing to the channel. Thank you so much. Do me the favor of sharing this information with those people that you know and love and some of the people that you hate on your social media. Let folks know that Fort Bend Tutoring is helping you out in many different ways in preparing for your academic endeavors. Amen, amen. And as always, please, ladies and gentlemen, like the video, share the video, subscribe and comment. And if you're able, please donate, as that helps us bring you more free math content from me, Mr. Witt, and Fort Bend Tutoring. You can use the subscription, not the subscription. You can use the donation link in the description box. That would be greatly appreciated. I want to say what's up to Simone, Saya, Derrick, and crew that chimed in today. Eduardo was in the house. We also had Angry Herman in the house. Michael Burns was in the house. We had Cherished in the house, tutorial YouTuber in the house. We had Samuel Mendy in the house. We had Saran Ansari in the house. Yes, we did. Yes, we did. We had some folks coming through. We had Obina in the house. Javier was in the house. Dupes was in the house. That's right. Evan was in the house. We had Tony and Noah in the house earlier today. Yes, we did. TK stopped by for a second. Yes, he did. And guy Shub Patel stopped by as well. So as always, please rate, comment, and subscribe, ladies and gentlemen. Remember that you can get some one-on-one tutorial from me, Mr. Witt, by going to our YouTube channel, tutormemath.net, and setting up a paid online tutorial with me, Mr. Witt. And you guys, peace.
Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutormemath.net, and set up a private tutorial with me and FBT. Oh yeah, baby. Thanks for watching. We appreciate you hanging out with Fort